implicit differentiation, finding the equation of a line.
Could we do the plotting an equation over the line?
Yes. You mean what I just said, find the equation of the line?
Yeah.
Okay, let me page, I found the page 359. So then find the slope of the curve or find the equation of the line. So differentiate implicitly to find dy over dx, and then find the slope and also find the equation of the line, of the tangent line to the graph of anything. We looked at all these, but we can choose anything, 15 through 28. Anything.
28.
28. Very good. So in 28 we have x squared y minus 2x cubed minus y cubed plus 1 equals 0. The point is 2 comma negative 3. And I know that the equation will be y minus negative 3 equals the slope x minus 2. All I have to do is determine the slope at this point. So I will differentiate implicitly. First function prime times the second one plus the second one plus the first one times the second one prime minus 6x squared minus 3y squared times the inner function prime. This is 0, this is 0. I have to solve for this, moving these two terms to the other side. So dy over dx, and I factor x squared minus 3y squared equals. This move to the other side, it becomes positive. This move to the other side, it becomes negative. So therefore, dy over dx equals this over this. 6x squared minus 2xy and x squared minus 3y squared. I need to evaluate this when x is 2 and y is negative 3. And this will be the slope that I need here. So, dy over dx is 6 times 4 minus, this is negative 6 times negative 2, positive 12. 4 minus, this is 9 times negative 3, negative 27. 24 plus 12, 36, negative 23. So negative 36 over 23. Ugly number, but that's what it is. Y plus 3 equals negative 36 over 23 times x minus 2. I should distribute negative 36 over 23x plus 72 over 23 and then minus 3. So what do I get here? 72 minus 69, so that is 3. So y equals negative 36 over 23x minus, actually it's plus 3 over 23. None of the problems requires so much work. You have 2 hours for the test. And I wrote 9 problems plus 1 extra credit. for 2 hours. I'm not asking you to finish in 10 minutes. You don't even have to finish in 1 hour. But there are only 9 problems. And everything was done in class or in some shape or form. Good. Anything else? Anything else? What
Lucy, can we go over some related rates problems?
Yes, of course. Absolutely. So that is the last section, and the page is 364. Good. Anything you like to choose? Anything you want to choose.
Can we do 18?
Yes. Very good. So that's page 9. 18 on 364. Yes, 18. Y equals PQ to the third. Find dP over dt when P is 80. Q is 135. dQ over dt is negative 5. dy over dt equals 7,654,500. How did they come up with that number? Okay, perfect. So this is the question. First, I have to find dP over dt and then plug in all this. Meaning I have to differentiate both sides. Of course, you can put a dot if you'd like, which means everything is a function of time. How do I know? dy over dt means y is a function of time. dP over dt, p is a function of time. So I'm sorry, this is q. dq over dt, they're all functions of time. So I differentiate the left-hand side, I get dy over dt. And now this is a product. I have to be very careful. The first function prime is dP over dt times q to the third plus the first function times the second prime. 3 times q squared times dq over dt. They want dP over dt. This is what they want. So I have to move this term to the other side and divide everything by q to the third. So dy over dt minus 3pq squared dq over dt equals q to the third dP over dt. Now I divide everything by q to the third. So dP over dt, q to the third, don't change anything, you have to copy it as is, dy over dt minus 3pq squared dq over dt. Now I'm ready to plug in the numbers. Careful how you plug them in, because, and especially when you put them in the graphing calculator. Q, 135 to the third, dy over dt, 7,654,500 minus 3p, 80, q again squared, 135 squared, and dq over dt, negative 5. Awful. Not that bad, but okay. So careful how you put it in. So, parentheses, 7, 6, 5, 4, 5, 0, 0, minus. No, plus, because the negative 3 and the negative 5, plus. 3 times 5, 15, times 80, times 135 squared, close, divided by 135 cubed, I didn't need parentheses here, but I put it, so now, okay, enter. Really very nice, if they say so. 12. That was 18. Any questions? Good. Anything else? Now, let me go back to the graphing with a simple example, because I want to show that. Okay, so we have a simple example. Let's say f of x equals x plus 2 over x squared minus 4. Oh, sorry. And I'm asked to graph. Of course, the first thing I do, I factor. Do not simplify, even if you can, before you get the problem started. Identify the fact that negative 2 and 2, the function is undefined. If the function is undefined, of course, its derivatives will be undefined. Then you are allowed to simplify, and you have x minus 2 in the denominator, which means this is a whole, and this is a VA. The factor that stays is a VA. The factor that goes away, the function is still undefined, but it's a whole. You will plug in 0, you will get negative 1/2. You know that the horizontal asymptote must be 0, because when x approaches infinity, the denominator blows up. 1 over huge is 0. So y equals 0 is a horizontal asymptote. Then you know that these are infinities. But what is the sign? This is negative with negative 2.1. I'm sorry. So around left and right of the asymptote of the of course these are infinities. With a 1.9, this is negative. With 2.1, this is positive. Here, when I plug in negative 2, I get negative 1/4. Negative 1/4. Of course, I have to wait until it dries out. Let me try this. Nope, nothing works at this point. So I'm just going to put it inside. And you know what I mean. So this is negative 1/4. That's not a good color. Maybe this one. Okay. So the whole is negative 2 comma negative 1/4. And there is nothing else we can find here about the function from the function itself. And when I differentiate to find f prime, so this is f of x, which is x minus 2 to negative 1. When I differentiate to find f prime of x, I get negative x minus 2 to negative 2, and then the second derivative would be 2x minus 2 to negative 3. So this function will always be negative, because the derivative actually is negative 1 over x minus 2 squared. This quantity is always positive, but it has a minus in front. So the function is always decreasing. Let's check. From 0 to negative 1/4, yes. To negative 1/2, yes. To negative infinity, yes. From infinity to 0, yes. The second derivative, however, can be negative or positive. So depending on x minus 2. To the left of 2 is negative. To the right of 2 is positive. And that's it. There is nothing else. So now we can graph the function. When we graph a function with asymptotes, we have to graph the asymptotes first. So this is x equals 2. This is an overkill. There is no need because it's already there. And negative 2, negative 1/4. From 0 to the whole to crossing the y-axis at 0, negative 1/2 to negative infinity. Very simple. And on the other side, opening down and decreasing. Opening down and decreasing all the time. And then opening up and decreasing all the time from positive infinity to 0. So this was f of x equals x plus 2 over x squared minus 4. And that's it. No problem will require this much work. If you spend more than 5-6 minutes on a problem, move on and come back to it, because you shouldn't. Have your notes ready. Don't forget your ID. They will not give you the test without a picture.